Hello, girls. So this is part 2 of the lesson of rules of differentiation. I thought we would split it up so that you don't die from the first lesson and being a bit overwhelmed, but I'm sure that you're all on top of things and that you are fully happy with what's happening so far. Okay, so just a quick recap that I want to do. Remember, if they give you a function in the form f of x, let's say equals 3x squared plus 2x plus 3, and I ask you to find the derivative of that, the correct notation we use is f dash x equals, and then remember we multiply the exponent to the coefficient, subtract 1 from the exponent, so this is going to give us 6x plus 2. Okay, and the constant 3, the derivative is 0. Okay, then we also looked at notation. So let's have a look. If I just erase the f of x on the left hand side and I put in instead y equals 3x squared plus 2x plus 3, the way that we then reflect the derivative is dy over dx is equal to 6x plus 2. Alright, so in this lesson there's actually a third notation that I'm going to introduce to you, and that in fact is, without even using the equal signs, we would have capital dx and the expression in a bracket. So that tells us we have to find the derivative with respect to x of 3x squared plus 2x plus 3. And once we actually find the derivative, in other words, once we apply the short rules, we can then drop the dx notation and replace it with an equals to show that the answer is 6x plus 2. Alright, a quick kind of explanation of this notation before we move on to further examples is if I said find the derivative of x plus 3 into x minus 2, for example. Before we can find the derivative, we actually have to multiply these two brackets out. So we keep the dx. We haven't found the derivative yet. We FOIL the brackets, so we get x squared, and then minus 2x plus 3x is positive x, and 3 times negative 2 is negative 6. And now we can find the derivative. So it's at this point that we drop the dx notation, and the derivative then is 2x plus 1. Right, so let's continue on from yesterday's examples. We did example 1a and b, if I remember correctly. So this is example c. And the question is, determine the derivative of x to the 4 over 4 plus 4 over x to the 4. All right, now, there are two ways of doing this. The long way is to combine the fractions and get an LCD. None of that's necessary. What we do want to do, though, is to rearrange these two fractions so that they're easier to differentiate. All right, so we're going to keep the dx notation. And what I mean by easier to differentiate is if we extract the coefficient out of each of the two fractions. So in other words, the first fraction becomes 1 over 4 x to the power of 4, and the second fraction becomes 4 x to the negative 4, because remember, because x is in the denominator, if we bring it up to the right hand side of the fraction, it becomes x to the negative 4, so it's 4 over 1, which in essence is 4. Okay, and now we can differentiate. So we drop the dx notation and multiply the exponent. 4 times a quarter, which is 1, x to the 3, because we're subtracting 1 from the exponent. And then in the second term, minus 4 times 4 is minus 16. Subtract 1 from the exponent, we get x to the negative 5. And then we're normally expected to leave our exponents as positive. So we can end off by saying that this is 16 over x to the power of 5. Okay, example D. Determine the derivative of g if g of x equals x squared minus 6x plus 9 over 2 times the cube root of x. Okay, so the first thing we do here is we need to, again, get it into a format that we can derive. And that means getting rid of the surd sign. All right, so we're going to have x squared minus 6x plus 9. And the denominator then is going to change to 2x to the power of a third. And remember, the rule there is that if we have x to the power of a in the square root, and that's raised to the nth root, we can rewrite that in exponential form as x to the a divided by n. In other words, the inside exponent divided by the outside value. All right, and then in our second step, we can actually split this fraction up so that we can make it easier to derive. So we have x squared over 2x to the third minus 6x over 2x to the third plus 9 over 2x to the third. All right, so now let's tidy up each of these fractions. So we're going to have g of x equals, now the coefficient is going to be a half, and then using exponent laws, exponent at the top is 2, exponent at the bottom is a third, so 2 minus a third gives us 5 over 3, as an exponent. All right, and then for the second term, 6 divided by 2 is 3. Now we have 1 minus a third. Remember, the top here is actually a 1. So 1 minus a third leaves us with 2/3. And then in the last fraction, we have 9 divided by 2. We'll leave it as 9 over 2 because it's not a whole number. And remember that at the top here is actually x to the 0. So 0 minus a third is x to the negative a third. All right, we are now ready to derive. Remember, again, one of the key things to doing differentiation is you need to get rid of brackets, and you need to get rid of surd signs, and you need to get rid of any variables in the denominator. Okay, so we've kind of done all of that in this step. There weren't any surd signs other than in the first step, but now we've gotten rid of variables in the denominator, and there weren't any brackets. So we can now derive. Right, so the derivative of g, so g dash x, we're going to say 5 over 3 times 1 over 2, that's 5 over 6, x, and then 5 over 3 minus 1, which is 2 over 3. Okay, minus 2/3 times 3 is 2. Subtract 1 from 2/3, we get minus a third. Last term, a third, negative a third, times 9 over 2 is negative 3 over 2. If we subtract 1 from a third, negative a third, we get minus 4/3. So for the last step, we can just express this with positive exponents. So the first fraction will be the same, 5x to the 2 over 3. Second fraction will be minus 2 over x to the third. And the third fraction will be minus 3 over 2x to the 4 over 3. All right, you will see some textbooks go even further than that and say that this is 5 over 6 cube root of x squared minus 2 over the cube root of x minus 3 over 2 times the cube root of x to the 4. Okay, it's not normally necessary to leave it like that in surd form. So if you leave your answer in that form, as long as the exponents are positive, then that's absolutely fine. Right, girls, can you please spend the rest of your double now doing exercise 2, page 181 of the purple Mindborn book, and you can do all of it because you do need the practice for this section. All right, so the idea is then I'll send the memo of this on, tomorrow evening. I say tomorrow because I'm recording this now on Thursday, so I'll send this by the end of day on Friday for you to have a look at and go through and mark.